इस क्वेश्चन में हमें दिया है कि एक पार्टिकल को हमने u स्पीड से प्रोजेक्ट किया। वी प्रोजेक्टेड अ पार्टिकल विथ अ स्पीड u and the value of u is under root of 380 meter per second. It is fixed, but the angle of projections are different. You can change the angle of projections. Now suppose we are projecting the particle from the origin and there is a point p in this xy plane having coordinates 6 comma 8 meters. So we need to show that there are two possible trajectories for this particle which can pass through this point p. And since there are two different paths, there will be two different time intervals for the particle to reach point P. So we need to find the difference between those time intervals. So let us see how we can approach this particular problem. Suppose we are projecting a particle at certain angle theta. So I am considering one trajectory over here, and suppose the particle reaches at point P in time t. So we will think in this particular way that a particle reaching at point P in time t, and there will be multiple solutions for this time t. There should be two real solutions for time t. So if we get two real solutions for this time t, it indicates that there are two possible trajectories through which particle can reach point P. Now, we know that in projectile motion, the horizontal component of velocity, which is u cos theta, is not going to change. So the horizontal displacement of particle is 6 meter from origin to point P. The horizontal displacement is 6. And the particle is taking time t to reach point P. So we can write u cos theta into t, which is the displacement in horizontal direction, which is given to us as 6. So this is our first equation. In the vertical direction, we are using the equation of s equal to ut plus half at square. The displacement of the particle in y direction is 8. Initial velocity in y direction is u sine theta into t and negative of half gt square. So I have replaced the value of g as 10 in this equation. So this is our second equation that we are getting. Now from the first equation cos theta, from the second equation sine theta, and I'm using sine square theta plus cos square theta equal to 1. So we are replacing the value of sine theta from the second equation and the value of cos theta from the first equation. So if you replace these two terms, you will end up with a equation only in time, which will be t power 4 minus 12 t square plus 4 equal to 0. And in this equation, you can see there is a term u, and we already know the value of u, which is under root of 380. So I have replaced the value of u over here, which is root 380. So you can do this basic calculation and you end up with this particular equation. Now I can say that this equation is a quadratic in t square, right? It is a quadratic in t square. So suppose there are two solutions for this is t1 square and t2 square, right? There are two solutions, t1 square and t2 square. Now we know the summation of roots. The summation of roots t1 square plus t2 square will be 12, which is minus b by a. And the product of roots t1 square into t2 square will be c by a, which is 4, right? So if t1 square into t2 square is 2, then the value of t1, t2 is going to be 2. Obviously, we are taking the positive solutions. Time cannot be negative. But we need the time interval for the two trajectories to reach point P. So we need t1 minus t2. So t1 minus t2 whole square is t1 square plus t2 square minus 2 t1 t2. So just replace the values of t1 square plus t2 square, which is 12, minus of 2 times of t1 t2, which is 2. So you'll end up getting a value of t1 minus t2 as 2 root 2 seconds. So there are two trajectories and the difference in the time intervals will be root 8 or 2 root 2 seconds.